Hi, welcome to Nomis Academy. In this video, I will be teaching you HCF. What is HCF? Highest common factors. Highest common factor. If you have not watched our videos on on factors, common factors, or prime numbers, prime factors, please go and do. So now we are going to be learning HCF, highest common factors of two or more numbers. So highest common factors. This question says find the HCF of 12 and 20. So how do we get into the solution of this? There are two methods. I will teach you the two methods to calculate. So in case you have complicated questions, you can use any of the suitable method to solve your question. So let's get into the solution. So the first method is just to state out the factors of the numbers, then find the common factors and pick the highest. So let's begin with 12 and then 20. So the factors of 12 are 1, 2, 3, 4, 6, and 12. So these are the factors of 12. And for 20, the factors are 1, 2, 4, 5, 10, and 20. Remember, factors are number that can divide number without any remainder. So these are the factors of 12 and 20. Now we need to pick out the common factor. What does common mean? Common means factors that appear simultaneously for both numbers. So we have 1 appear simultaneously, we have 2 appear simultaneously, we have 4 appear simultaneously. So these are the three factors that appeared simultaneously for both factors, for both numbers. So which of these factors now is the highest? That is what we pick as the HCF. So that is 4. So the HCF of 12 and 20, meaning that a number that can divide, the highest number that can divide 12 and 20 without any remainder is 4. So the HCF is 4. So what other way can we do it? In case we have complicated questions, there are other simple ways that it can be used to solve this question. What we do is we keep dividing each of those number by 2. So let's take them one after the other. So let's take 12 first. So let's keep dividing 12 by 2. 12 divided by 2 gives us 6. 6 divided by 2 gives us 3. So now that 2 can no longer divide it, what can divide it? 3. So we now have 3 divided by 3, 1. So 12 is written as 2 multiplied by 2 multiplied by 3. Now what about 20? Let's do that of 20 here. 20 divided by 2. So we have 10. 10 divided by 2, we have 5. And what next? 2 can no longer divide, then 5 is the next, so we have 1. So 20 is written as 2 times 2 times 5. So when we are able to express the number by their prime factor, because that's what we just did, we just express those numbers by the product of their prime factor. So we are going to now pick the prime factors that appear for both. So 2 appear for this, 2, and then also these 2 appear for them. Well, 3 here we don't have 3 here, 5 here we don't have 5 here, so we'll not pick 5. So the product of this that appeared is the HCF. There, say HCF is equal to 2 multiplied by 2, and that gives us 4. So you can see, you can do it this way, just to divide with factors. Then you pick out the common factor that divide any of them. Then you get the HCF by multiplying those ones that come out like this to get the HCF of the two numbers. So what happens when we have more than two numbers? So let's take another example. Example 2 says find the HCF of 100, 50, and 36. So let's get into the solution. Which of the methods should we use now? Okay, you want to use the simple one. So let's use the 2. The first one, let's begin. 100. Let's find the factors of 100. Factors of 100 include 1, 2, 4, 5, 10, then 20, then 25, then 50, and then 100. So these are the factors of 100. Then that of 50, the factors are 1, 2, 5, 10, 25, and then 50. Then the last one, 36. What are the factors of 36? 1, 2, 3, 4, 5 is not a factor, so 6 is a factor. 6 times 6, then 9 is another factor, because 9 times 4 is 36, then 12 is another factor, then 18 is another factor, and lastly 36. So let's find the common factors. Common factors are 1, 2, which other one? 4, we have 4 here, but we don't have 4 here. 5, we have 5 in these two, but we don't have 5 here. So 1 and 2 are the common factors. Only 1 and 2 are the common factors. Therefore, the HCF, the HCF of these three is equal to 2. So you can imagine the highest common factor is equal to 2. If you solve it the other way around, you are going to get the same answer. Let's get it. 100. So let's get to divide 100 by factors. So this we have 50. 2 again can go, we have 25. 2 can no longer go, then 5. 5, then 5, 1. So we are going to have 100 to be 2 times 2 times 5 times 5. Then the other one, which is 50. So keep dividing by 2, or let's say by factor. So 50 divided by 2, we have 25. 2 can no longer divide, 3, 4, 5, then 5. 25 divided by 5, we have 5. So the another factor that can divide 5 without remainder is 5. So 5 divided by 5 gives us 1. So we can now rewrite 50 to be equal to 2 times 5 times 5. And then the third one now is 36, right? 36. So let's keep dividing 36. 2. 36 divided by 2 is 18. Then 2 can still go again. That gives us 9, but 3 now. 9 divided by 3, we have 3. Then 3 again. 3 divided by 3, we have 1. So 36 can only be written as 2 times 2 times 3 times 3 in the product of its prime factor. So when we look at it, we have 2 appear ones, 2 appear ones. So we have the HCF now. We are trying to figure out the HCF 2. Then we have 2, we don't have 2, we have 2. So since it's not general, 5, 5, we don't have 5, 5, 5, we don't have 5. So 2 is the HCF, just simple as that. 2 is the HCF of these three numbers. I believe you understood everything we did in this video. Bye bye. See you in the next video.